Hi, all, and welcome back to part 2. In this part, we're going to be talking about 2D plotting. So what are two-dimensional plots? Well, a 2D plot shows data in an X and Y space. And that just means that there's an X coordinate and a Y coordinate, and there are some values being shown in that frame. So you can think of maps with longitude and latitude, with some value being shown inside. So if it's depth or topography or some concentration, that is a two-dimensional plot. And even though maps do get a little more complicated, at their base sense, they are just a two-dimensional plot still. You can think of transects. So we have a transect here, depth and latitude. You can see temperatures being shown in that frame. So it's a two-dimensional plot as well. And then finally, you also have time versus distance evolution, also known as Hofmüller plots. And that just looks at how an area in space evolves in time. So it has a time axis and a space or a distance axis. So these are some of the more common two-dimensional plots in geosciences. But how do we get these things in Python? Well, we can start with a contour plot. So here we have plt.contour, and then our x coordinate, our y coordinate, and then our z, which is just the thing that's being plotted in those frames. And then we have all these optional formatting. So we can tell it the number of levels we want, which is just the number of lines that are being drawn. We can give it the colors or a color map. So if we do colors, it's just one color across all the lines. If you give it a color map, it actually changes depending on the magnitude of z. And then we have our line widths and line styles and line formatting arguments. Notice that colors, line widths, and line styles are all plural, so they have s's at the end there. And that's a little bit different than what was happening in line and scatter plots, which were only color, line width, and line style. So be aware of that and make adjustments if you're using contour and formatting in that way. So contours are used to show the z data on that two-dimensional plot with corresponding x and y axes, which means that the length of x has to have the same number of columns as in z. And same thing with the length of y has to have the same number of rows in z, so that the grids can sort of match up. So here's an example. From the World Ocean Atlas, I've taken the oxygen data. Before we're working with temperature, and I went and grabbed the oxygen. And this is after assuming my drive has been loaded and it's in my file and everything. So I get my file path and I load my data set. And we display it, and you can see it has a depth, a latitude, a longitude, and just one time. And you can see here, I now take out that oxygen as my data variable, and I take the mean along the longitude. So I'm basically squishing it down into just being latitudes across the whole globe. And then I just take out that time and say, oh, that very first time, that's the one that I want. And I get the values of that to make it a NumPy array. And then I get the latitude and depth. So that's going to be my x and my y coordinate. So if I plug that into a contour plot here, so I create my figure, I get an axis object, and I say my contour plot equals plt.contour with my latitude in my x, my depth in my y, and then my oxygen data is the thing being contoured. And I create a color bar because you can see here that it actually does have variable color. And that's because I didn't designate either color or color map. So the automatic is a color map that is this default Viridis color. And I set my label for my color bar, and I do all the formatting, noting that I invert my y-axis to be in an oceanographic frame. And you can see this is sort of what it looks like, where we have these lower oxygens in the middle here and sort of higher up in the poles. Now if I add the argument of levels equals 20, you can see now I'm getting 20 lines plotted on this. So you can see there's a lot more lines than there were before. But it still has that same color, and it's not very much different other than just a few more lines. Now, if I put colors instead of just adding more levels or changing a color map, you can see that it just creates all of these and makes them all black lines, which means I don't need a color bar anymore, but it also means that I don't know what each of these contours means. So I need to add a label to them. And you can do that with plt.cLabel, and you give it the plot variable name that you created. So you say plt.cLabel of your plot variable, and these are optional formatting things. So you can determine the number of levels that are labeled. You can give it a font size, and you can actually change the color of your labels. So here I'm actually changing the labeling You can see levels equals, and I put this variable for my contour. And I say my variable dot levels. So it's getting the levels from this. What I'm saying is label every other one. So I'm going to label all of them every other one, right? So every 2. So here there's one labeled, skip this one, the next one, skip it, the next one, and so on and so forth. And it creates sort of a neater figure in that way. So that's the basic of how to get the lines, but sometimes you want to fill in the lines and make sort of longer, bigger grids. And you can actually do that with a contour F. So it's very similar to contour. We have an X, Y, and a Z, and you can use levels. And here you should put in a color map, but then you don't have line widths and line styles. That only applies to contour. And it just fills the space between the contours using the color map and interpolates between those things. So here's what that would look like if I say plt.contourF of my latitude depth, my oxygen, and my levels being 20. And you can see this is what it sort of ends up looking like. And you can see each of the sort of contours are filled in between, and it interpolates between those things. So we need our color bar back because we've now added color back from our just black lines. And we can also change our color map. So you can see we changed it to a plasma color map instead. And we can also add those contour lines back on. So here you can see I've created my contour F, and then right on top of it, I put contour. And that's, if you notice, the thing that I am labeling is contour lines. So you can see that now I have all of these labels, and it's sort of really highlighted all of those contours. So that's the basics of contour plots. The next 2-dimensional plot we're going to talk about is a pseudocolor plot. And it's very similar, where we have plt.pcolor_mesh. So that's pseudocolor mesh. And then you give it an X, a Y, and a Z. And then you can give it a color map. And then you can give it line widths and edge colors. Those line widths and edge colors are a little bit different, where they are actually the grid lines and the grid edges of the map. So here you can see we have PLT to color mesh, lat, depth, oxygen data, and our plasma color map. You can see we create our color map, color bar, and everything. But what is the difference really between contour F and pcolor mesh? Well, pcolor mesh is good for noisy data or sort of bigger data sets because it doesn't do all of that interpolation that contour F does, but it tends to be a little bit more gridded. So if you look really closely here, you can see sort of the gridding in this, whereas here you can see the interpolation sort of that it creates these lines through it instead. So this is better for looking at like large scale patterns for contour F and better for noisy data for pcolor mesh. And also if you have really big data, pcolor mesh tends to do a little bit better. So that's all for our 2-dimensional plotting. And next we're going to get into our mapping.